Good afternoon, everybody. I don't see anybody here in the chat yet, but if you're joining, please say hi. I'm trying a little different thing today. I usually wear those big headphones, but they're a bit heavy on my head. I'm going to be wearing them a lot this week for work, so I'm going to try to go without them today. Hopefully the noise is not too bad, um, and I won't have too much feedback from the computer audio into the mic. If we get that, then I'll switch to my earbuds or something. Hope you all are having a good Sunday, and we'll get started in a few minutes after we get seeing some people in here. I'll put a quick note out on social media again that we're getting started, and yeah, hope you all are having, like I said, hope you are having a good weekend. I've had a pretty great one so far. Last weekend, which I missed the stream, we were missing it because we were at a playoff soccer game, and Sporting Kansas City beat St. Louis City FC, and I'm pretty happy about that. We go on to the next round. And last night had the great fortune to be at the Thunder Gong event, which was a charity event put on by Jason Sudeikis and a bunch of his friends, and it supported the Steps of Faith Foundation, which was trying to give money for people who have lost their limbs and can't afford to get prosthesis. So it is it was a really great event. Basically like celebrity karaoke. But of course, Hannah Waddingham was there, and she made them all look like fools. So was Nathaniel Ratliff, and he was great as well. So really great event. They raised 200 grand more than they did the previous year, so that was great. And I'm just sitting here rambling, and I don't see anybody in chat yet. So let me get that note out, and we'll say we're starting now. And we're going to do more Tree Sitter today. I hope folks are still happy with that. We will. I know that I ran the poll over a month ago, I think, asking what should I do next on my stream, and I think we will get to Bevy, but it'll be interesting because I am not that experienced with writing graphics or game stuff, so it'll be interesting to see how that works out, and also the simulation, so to speak, that I wanted to do is very lockstep, and Bevy's kind of more about real-time ACS. So I'm not sure if that will turn out to be a challenge or not. And we'll repose, or rather, quote that. Cool. So let's get started. I believe I was over here. Okay. I got my screen set up. I think we're good. And apologies, I haven't had any lunch today, so I might be snacking on some popcorn and drinking a little coffee while we are coding. So let me switch over to our coding. So we did previously the basics of attaching the Tree Sitter library, which is like parsers, so you can query text documents that have structured languages in them, and so we had it so you could set up a parser, and we had it so you could execute some queries, and then we turned those queries into Elixir data structures using the Rustler bindings to create Elixir structs. And we were still thinking about, like, how do we expose this Node API? I don't know that we've solved this yet. or if we have any idea what we're going to do there. But we might look into that today. I'm not sure yet. We did talk about potentially creating iterators. So if you wanted to walk over the entire tree, we could yield the nodes back to the Elixir code, and or potentially let you look up nodes by their unique IDs, because every node in the tree has an ID. And if we're actually doing the API like I think we should, which we haven't managed to yet, we will be giving the possibility to reuse a tree and pass the new text or the edits to it to the tree sitter API, and then it can keep those IDs in the document consistent, and just create new IDs for areas of the document that have changed. So this would be more about like if we have if we're using inside a text editor, and the text editor is sending that information to like the Elixir language server, then we can pass that new document through reusing the tree that we had for it before. Okay. So those are the sorts of things that I'm thinking about right now with Tree Sitter. I was looking at where we were from last time, and let's pull up Zed. So last time we implemented this queries thing, which this gets out of the linked crate. This gives the static queries that are defined. And if you remember right, in Elixir, we had like the highlights query, and some others. So let's there was I think the EEX or HEEX template query, and there was also one for tags. So that was kind of like, what are the symbols in this project, if I recall correctly. So let's just see if I might need to, I did update Elixir, I think, and OTP. So I might need to recompile. Hi, welcome back, Isaac. So let's do a mix clean here, and compile and make sure we're doing okay. And I don't actually need 2 tabs right now. Okay, so let's run IEX-S mix, and let's get a code file from our own project here. So I think this has nothing in it, but we could get something like the NIF file. That'll be interesting. Okay. So let's say this is the document. File.read libtree-sitter-nif.ex. Okay, so we've loaded the Elixir document there, and now let's go back to our, we're going to make a new parser, and we will, and maybe that's a good thing to do today, wrap these up so that we actually get something that hides the internal references inside the beam for these resources, and gives you back something that's a little bit more opaque. We may do that today. Okay, so we have a parser, and then we're going to say parser parse, and that takes the parser that we just got and the text. So there's our document, and this is going to be our tree, right? So that is also a resource internal that we'll want to wrap inside a struct. Okay, and then let's look at, I think we added this, no, okay, so this is one thing we didn't finish, is that we created that NIF, or we created the internal structure inside the NIF for getting those queries out of the language, but I don't think that we, oh no, there it is. Okay, so let's get queries equals tree sitter dot not NIF, dot language queries. I was just under language rather than queries, so I got a little confused there. So we get the queries for Elixir, and then I don't know. Let's run the tags query. So we will run. Let's say this is a result. NIF query matches, and we're going to give it the tree that we created, and we know it's Elixir is the language. The query is queries.tags, and the source is the document. So remember, we have to keep that document around. It is kind of frustrating that we have to keep that around, but I don't know any better solution for it. And honestly, I'm not that worried because the binaries are shared. It's not like we're going to be creating copies of this over and over and over. They're rough counted, any bigger than 64 bytes. So, okay, and let's explode that up so we can see more. Okay, so we got a bunch of query matches, and this is the stuff we did last time. So, not seeing that that seg fault that we saw previously, which is really good. So I'm glad about that. And we've got a pretty nice nice result here. So like here's a function definition, and you know, here are individual name. Oh, okay, so this is capture. So we will need to maybe understand what this pattern index thing, or maybe we just need to know about the query itself. So, all right, so this is capturing. Okay, so this particular thing is capturing a function definition, and here's the entire text of the node for that, and this name is def, I'm guessing. So this is saying this is a public function. That's why it would be important for tags if you're just trying to search for the symbols in the project. Yeah. Okay, so I think we've got some pretty good stuff there. We just don't have the high-level API wrapping that together, and we don't have that way to iterate over the tree from a low level. And you know, again, I don't know a simple solution around this. Some of it has to do with the fact that in the tree sitter documentation, you can see what I do every day. So in the tree sitter documentation, we have, you know, if you get a node, it's got this lifetime in it, which means we can't really, that lifetime is bound to the tree. Now we know that, and maybe there's something we can do here with our resource. Maybe we can, instead of wrapping the tree resource directly, let's look in here. So right now we just have a mutex around the tree. And maybe what we need to do is also potentially okay, so the issue here, I think, is that even if we have this tree, you know, when you get, let's look at the tree struct here. So if you get the root node, you know, this kind of has an anomalous lifetime, but if you see in the other file or in the other documentation for the node, it's saying that lifetime, you know, it's labeled tick tree. So I think they're trying to imply that the validity of this struct, even though it like has low-level raw pointers in it, inside it, we've looked at the source before, that it is bound to the lifetime of this tree. So, and interestingly, it's not ampersand node. You know, it's not a reference to a node. It's the actual node, but the reference is inside it. So, yeah. Now we can also look at, there's this tree cursor that lets you start walking a tree, and in this case, these nodes are bound by the lifetime of this cursor. And I think that this is like, this tree cursor, you know, inside has a reference. It's probably a raw pointer again, to the tree that it came from. So, one thing we could do, we could, let's look at what we're doing here on queries, right? So we just made this node, um, and we have this from TS node function that constructs our own node, right? So this is a tree sitter node, and we're given the source, and we want to return something that can actually be passed to Elixir without any concerns about lifetimes. So we called a bunch of functions on it, and then yeah, and we had, we'll probably want to change this a little bit, um, but this is still useful information, right? So you get the stuff that you might want to know about a node. Let's go back to that documentation and see if there's anything else on here. The downside is that, this has the ID in it, I think. It does not. We can probably put that in there. That would be useful, right? So, okay, and this is that thing I was talking about earlier. The IDs are consistent across if you modify the tree or not, or if you give, a new tree, it'll have the same ID. So, I think we should do that. We should add the ID in there. We know that the language, I don't know that we need to include the language in this. We did include, is it named, is it extra? We aren't doing things like, has it been edited? Now, I don't know if that's going to be useful for this API, but I kind of want to consider exposing a lot of things. Has error, I think we definitely should do. Hi, Mitch. Hello, Hassan. Welcome to the stream. Okay, so that's also interesting. Is missing. We don't include the start byte and end byte. We might do something like, hey, this is one of those range structures that we created. So like we have start byte and end byte, but we don't have start point and end point unless it's on here. Yeah. So we could do this. We could put the byte ranges. We could actually even just give it this range thing, even though that's not. Oh yeah, this is exactly what we would want. Now the next question would become, if we have a node and we get its ID, can we go back to the tree and say, give me the node in this tree with this ID? If you could do that, then we could do this this indexing thing. That might be pretty useful. And so let's go back to the tree real quick and see. Let's just jump there. No. We only have root node. And you can walk, which gives you that tree cursor. Okay. Well, let's go ahead and maybe let's start by enhancing what we're returning in these nodes. I think that, I'm sorry, that's the tree cursor. Let's go to the node. I think that we definitely need the ID in there. We have the other things. We should change this text to be an option string so that you could potentially not pass the source. So if you're in a situation where you don't have the source, we could do without it, and you just wouldn't get the text of the node. All right, good luck, Mitch. Painting is fun. Painting is messy. Okay, so Yeah, let's start by making this, and we will need to look at the other places where we call this. Um, and that's another thing that we could do potentially is have that be optional elsewhere. But let's get started here and figure out the fields we want to add. So we want an ID, and that ID is a usize based on the tree sitter API. And let's make sure that we have, so you don't need that open right now, or that, or that. Here we go. Let's close that. And we don't need language. Git ignore. Cargo tunnel. Okay, so I think we have the things open that we need right now. Okay, so we need to add the ID. And we had kind ID in kind, and we had is named is extra. Let's just throw all this gunk in there. I think honestly we will not know right now if we need it or not, and having it in there will make it easier to do things later. Okay, there is some inefficiency in this potentially, but and let's not do start byte, end byte, byte range. Let's just do this range, which is this thing, and right, we could do child count. Yeah, okay. Right, so should use named children instead. Okay. Hi, Pixie Report. Welcome. Thank you for coming. Glad you saw it on Mastodon. I know Twitter's still a thing. Not everybody's on it, but I've been on Mastodon for, I guess, over a year, and I'm loving it. So welcome. Yeah, we are doing Elixir, but we're going to do a lot of Rust too, because we're writing a NIF. So please bear with me. So these are some traversal things: parents, next sibling, previous sibling. I don't think that we can expose these reasonably right now. I'm just trying to get the stuff that's just pure data, like well, that might be interesting. 2s expression. It doesn't say what the, yeah. So we did the UTF-8 text before, right? I don't know that 2s expression is something that we can reasonably. It might be expensive to compute that because it's probably doing formatting, string formatting underneath. Okay, so I think we're good. Right, and I don't think it's implementing any interesting traits that we need to call. No, just the regular stuff. Okay, so that's a good place for that. So now let me split right on this, and then we need to fill in these things that we added just now. Has changes bool, has error bool, is error. That might be a little bit confusing to folks. Is missing. The documentation is probably important to add on these, and I'll when we get closer to publishing, we should probably go back and look at that. That's going to be our range, I think. Did we define that in here? I don't know if we defined that range struct in here. Yeah, we did right here. So we'll want to, yeah, we'll want to do that. Okay, range. Oh wait, we already had range. Ha ha ha! How about that? I should have remembered because we were looking at the output earlier, and we had range. So we didn't need to do that twice. Whoops. I'm sure Elixir would go, hey, you can't have that field in your struct twice. And let's see. Whoops. So we had range. Okay, so is missing and child count. And I believe that is a usize. Yep, that's a usize as I expected. Okay, let's undo that split. And we'll save that. And let's save that. And now what we're going to need to do, it's probably saying, hey, you didn't, yeah, it's the errors are all misaligned. It thinks it's in that file, but it's actually over here. So we need to fill in the rest of these fields. And let's just say we started from here. So let's just copy down here and see what we get. And I might, because these are, you know, I did a lot of this up above. Oh yeah, we were going to change text to option of string. There's honestly not really a reason to do those all as bindings. We can just put it here in the constructor. Child count is missing node is missing node.has error, which is different from is error. Okay, and I think I don't know if this code action is going to work. No, it's let's just do this. And I think we'll leave the text up here because we'll want to use some stuff with option, because we want to make this optional, right? But I'm going to inline into the constructor all of this. This is safe. Range, yep. Oh yeah, so last time we did, we implemented the from trait for tree sitter range, which lets us, you know, construct our own struct, which is kind of a parallel of this. And then, you know, we can convert the points into, interestingly, they're the same layout. So we probably could have done some unsafe memory transmute, but there's no reason to. Honestly, the compiler will do well on that. It'll go, hey, these have the same layout. I'm going to throw them, you know, into simple copies. Okay, so now I want to. I was trying to remember the context of the text, and I think there was a case where we were, oh right, so if we have an iterator, we're not necessarily passing the source in at all times. So we'll get back nodes that we don't have the source for, but we'll have all this other information about it, right? So I want to make this optional. And this is interesting. I could make this an option of a slice, or yeah, let's just go with this for right now. It could be also option impl as ref u8, but we're going to change this text to option of string. And then if you don't pass the source, then you know you don't get the text out. And we'll have to see the other places where we call this function to construct a node and make sure that we're passing an option there. Yeah, so now we're going to do, we're not, I kind of want to remove this expect. Yeah, yeah. So let's rewrite this line. I'm just gonna comment it out. Okay, so what we want to do is take the source, um, and then we'll do and then. And then is one of my favorite new functions on standard option. So where did and then go? So and then is it's like fmap, flat map, or bind. Basically, if the option contains a value, if it's not none, then it'll pass that value into this function, and your function returns an option. So it's like monadic bind, which is great because we can do. So if we have and then, if we know we have the source, then we can take node.utf8 text source, and this returns an option, I believe. So let's go down. Where's that UTF-8 source? UTF-8 text. No, this returns a result. So we actually need to use one that returns a result. So I think we can do the other possibility is that we can swallow that result. So we can do .ok on the result, and that will return an option. That could work. Yeah, so let's look at result here. It's funny, I don't know about you all, but I've been programming a really long time, and I live in the documentation. If you're not doing that, I don't know what you're doing. Yeah, so it's just like I remember things, and sometimes the editor actually helps me when it doesn't think it's an Elixir project. It thinks it's a Rust project. Anyway, so this says okay. It returns a result into an option. So basically, we're getting rid of the error value here, which is not great, but in this context, we don't actually care what that error was. If you weren't passing UTF-8 text to begin with, I don't know how to help you. So then we have, so this is going to give, if we look at the documentation for UTF-8 text, it gives a string, or stir rather, so like a borrowed string, and then we'll map that to, so if this is a stir, then we'll map it to toString. And then we have an own string from, so it'll copy whatever's necessary there. Yeah, I also, Pixie, that's a good point. I also live in MDN frequently. My day job, we are building a mostly client side web app, and doing some stuff in Rust and in TypeScript. So I spend a lot of time at MDN. I feel you a lot. Okay, so let's check in on the compiler. Yeah, control key. It doesn't know what exit is. Okay, so let's see if it compiles. Yeah, so we're getting right. So I made a mistake there. This is not source. This is S. And let's see if that compiles. Okay, so what do we have wrong here? Now we're getting cases where we're passing the source and expected an option, and we're passing the actual slice. So let's go up and see where we're calling this. Right, so here it's required. So we may need to propagate this bit up. One thing that still requires looking back at, and for now I'm just going to say some source, and we'll fix that potentially later. But this was to make it so that we could potentially do an iteration over the tree without the source text. Yeah. Okay, so that should solve that compilation error. And missing ID. Yep, so we didn't do that. Thank you, compiler, for finding my issues. Node.id. Okay, so it is doing just fine. Hello, Maciek. Welcome to the stream. How are you doing? How is Warsaw this time of year? Hope it's good. Okay, so right, I think that we went way, yeah. So what we could do, um, let's look at this constructor for query, and I want to see if if like option of a slice is acceptable for a query source, or option of a string. Nice. Enjoy skiing. That's sounds like fun. I haven't skied in 20 years, so I'd probably hurt myself. Good to see you too. Okay, so let's look at that. We're constructing a query. Obviously, the query cursor doesn't need that, but this is like this text provider thing, if I recall correctly. So let's look at query. Yep. Okay, so no, it's just, it has to be a stir. So I think for this case, there's no sense in propagating this optional above the constructor for node. And then what we should be able to do is, let's say we might create a function that returns the root node of a tree, and it will call this but without the source. And so we would pass none for this argument, but we would still get out, useful information. Just this text would be empty, and it would be nil on the Elixir side. So let's run some stuff again like we did earlier. Yeah, I think I cleared out and I don't have global history set up on this machine, so we're not getting the up and down arrow keys except for in the same session. Okay, let's do our usual. So our document, or maybe we say our source, just to be consistent with the rest of our code. Let's read lib tree sitter nif.ex. Okay, and then we need a parser is tree sitter.nif parser new Elixir. Okay, and our tree is tree sitter.nif.parser parse, and that takes, okay, so it takes the parser and it takes the source. Okay, so we have the tree, and then we are going to do result. I just want to see that we are getting the same stuff, and when we produce the node, we are we've got all those fields that we just created, and it doesn't crash. So let's do query matches. Oh, we have to get our queries. Language queries, Elixir. And let's do highlights this time. It's going to be a bit longer, I think, than tags. Yep. Query matches. That is nice. Hey, Elixir, you keep making things awesome. Thank you. Tree, what does it take? Tree language, query source. Okay. Queries.highlights and source. Okay, and so that is still working. It is like alighting a lot of this. So let's see. Let's just look at the first one. Oh, okay, fine. let's do head of that. Okay, so our node, there's its ID. It's big, and it's got a comment. Okay, so we got a bunch of new information. It is a named node. That's interesting. It is also an extra node, so it's not syntactically significant. I think that's what the extra means. It has no changes. Doesn't have an error. Is not an error node that was inserted. It is not missing. It has 0 children. The index of the capture was this, and the capture name was comment. So we got all that information that we just added, making a better API. That's good. And you'll note here that text is just a binary. There's no wrapper around it. It's not okay text. It's just the text. And if it were missing, it would be nil. So maybe what we do next is let's make a really simple one. Say tree root node. And it takes the tree. And we will do this. I kind of would love to make a little def NIF macro at some point. But I don't know. It's not that important. I'm okay copy pasting. Okay. So then we need to go into our NIF, and we need to add tree root node, and we're going to have to make a new one up here. I don't know if we're just going to keep making these dirty CPU. I think that I'm pretty certain that the root node call is going to be 01, or at least generally speaking constant time. So I don't know that we need this dirty CPU, but it's honestly probably just safer to do that. Okay, and then we're going to take a tree, which is a resource arc of parser tree. And this is going to return, let's see, tree. This is infallible. So what we can say is this is and we're going to move I think we need to move that node. It is relevant to queries, but it's not solely about queries. So yeah, we'll move that later. Okay, so we've got the tree. And we need to go over here into the parser and see what we have available on the tree. So it derefs to that. Let's make that function. And this is going to return query crate. I need to be more specific there. Node. Okay, so we will do. What did we do? Yeah, so we did stuff like self.0.lock. Right? Yeah, and I don't. We're not doing try lock here, but lock does return a result. So I think I'll just do an expect, and then I don't really want to panic here, but I don't know a better solution. Like if you can't get the lock, this is one downside of using Rust for a NIF. It expects more safety out of your NIF than other things would, and like while this is, I conceptually I know there's no chance that this is locked by anything else. Like this is running on one processor, on behalf of one process, and that process is the only thing that has this tree. Now we can, because we put this in mutex, you can pass this around, and it would be safe to. But I would find it very unlikely that that lock would become poisoned in any case. So here, like, I don't know. Let's just do unwrap. I don't know what the valid message would be. Okay, so if we have now we implemented deref for tree, so we could just do, oops, I don't need the emoji right now. We could just do self.lock, I think. Let's make this pub, because we want to expose that to the parent. Okay, so then we're going to say, now we'll have a mutex guard for that tree, and then we will say, so we can treat it as if it were the tree sitter tree. So we can call root node on it, and we'll do that, and then we'll say create query node from ts node, and this is what I was getting to earlier, is that we can pass none here, and it won't give back the text, but we will get the root node with all the other attributes on it, except we want to return that. Okay, so in here we'll do tree dot root node, and that's it. Make sure we're correct over here. Yep. Interesting thing about Rust here, the mutex, you don't need an exclusive reference to it. You can do it with a shared reference. Okay. Yeah, let's go and see if we can compile again. Yeah, okay, so we have, so this takes a reference. So I was passing the whole thing, and I need to pass a reference. Okay, right, so here we need to inline this. This is a case that I actually don't care for about the way Rust works, is that it can't tell that this doesn't escape the scope, and so we have to do it inline, so that it knows that it can't get outside that call. I run into that in my daily work all the time. It's kind of frustrating. It's like, but it's more clear if I make it its separate variable. Now, potentially what I could have done here is made another scope, like making a block around it, but I don't know that would solve the problem. And this is fine. So now let's clear this up a little bit. Use create query node, and then this doesn't have to be qualified. Okay, so recompile one more time. I didn't implement the node or the NIF reload, so we're not going to be able to do that directly. We're going to have to run our commands here again, unfortunately. Okay, so let's make our source. And I should maybe make a script that will set this all up for me, that I can eval as we start IEX. Lib tree sitter nif.ex. What did I do? Nix, not nix. We're not using nix. Okay. And the parser is treesitter.nif.parser new. Parser, no, not parser, Elixir. And our tree is treesitter.nif Parser parse, and that takes the parser and our source. Okay, so now we should be able to do tree root node and pass the tree. And yep, we got back the text, the node. Now we did not get the text of that node, so we don't. Now you can see here that's probably that first line, right? In an entirety, it doesn't say. It says it's this kind is source. Oh right, so no, this is the entirety of the tree. This is the soup. So this is from row 0 to row 31. There's only 31 lines in the file. Yeah. Okay, so I think we might be at a spot, given all this, that we could maybe think about an iterator. And I think let's just make a no. This comment was here from last time, or maybe the time before that, where it's like, yeah, we would love to do this, but we can't because of this freaking lifetime, right? Can't do it. Okay, so let's do. Let's start in the Rust code and actually let's start and define our NIF up here, because I want to do. We're going to do pre-walk, and it's going to take the tree. Okay, and then what we're going to do is go to our bindings, and we'll do basically this. And we'll say this is pre-walk. And this is going to be a vec of nodes, right? So we want to return a list of all the nodes in pre-order. And I think we'll just delegate it like this. So what do I mean when I say pre-order? I mean that you start at the root, you emit the root, and then you follow all of the left branches, emitting them as they go down. And then so you do all of the children, and then you go back up a level, and then you go to the next child of that, and you go down and emit its children, and so forth. Whereas a post walk would be you go all the way to the bottom and you emit all the leaves, and then you go up a level. So you're actually emitting them as you leave the node, even though the traversal is the same order. You emit them as you leave a node rather than as you enter the node. So you would get the root last. So we'll do a pre-walk first, because I think that's fairly easy to understand. Now, one of the challenges is you will not get. Let's look at node again. If we do this pre-walk without adding any information to the node struct, you won't get what was the parent node of this node. Like, what is the ID of the parent node? Now, we may want to do that just so that you could, in Elixir, build up your own data structure, but I'm not sure yet. So we could do something like call parent, and which gives option of self on node, and then map into that, extracting the ID of the node. But I don't know that we need to do that yet. The challenge of that too is that if we do that, then every place that we call, so if we're executing a query, and we say, hey, construct me a node from this, we will have to include parent ID in here. I guess that's okay. Let's see. Yeah. Okay. So let's, we define this in here. Let's put it in our NIF definition. Tree pre-walk. Okay, and then we will have to go in and implement that on the tree struct. Pre-walk self. And this is return a vec of node. And this is where we'll do most of the work. So so again, one of the challenges here, and this is actually a case where I'm thinking, oh yeah, having that mutex is good. Even though at first I was like, God, maybe we can soften it to a read-write lock. I don't know. But maybe having that is good, because if this pre-walk is going to allocate a bunch of memory, and it's going to iterate over the entire tree, which is potentially, CPU intensive, memory intensive. So it's probably better that it is locked, even if it's just a read lock. Then if some other thread, some other process comes in, is like, and has this tree and wants to do something with it, that it will be, it'll be safe to use on the thread, or it'll just be, in the case of the mutex, and it'll just be blocked. It won't be able to do anything until we're done here. It's not really good for concurrency, but honestly, these things are not likely to be shared across processes. But having the mutex gives us some safety here. Anyway, I'm rambling. So I think what we want to do is we're going to say let tree is self.lock.unwrap. Okay. So how will we do a pre-walk? Well, let's look at, let's say, let mute current node, tree.root node. And then we are going to do we probably need something like a stack. And maybe this is not current, but maybe we do let's say the stack, right? So we need to probably like a while loop. And what we're going to need to do also is we're going to need to have our output is an empty vec, right? Okay, so while not stack is empty, because what will happen is if we get to the end and we visited all the nodes, then let's see, pre-walk. We might need a vec deck for this, actually, for the stack. Okay, because if we're going, and I need to see if there's something I can draw with to show what I'm talking about. Let's see. Arc has easels. New easel. There we go. Okay, so let's say the tree. This is awful. And we've got lots of nodes in it. I'm just gonna make it, it's gonna be unbalanced, right? But we need to talk about pre-walk versus post-walk. So these are all, basically it's an adjacency list type of tree, where the parent lists its children, but you can visualize it like this. So let's say this is 1, and this is 2, and this is 3, and this is 4, and this is 5, and this is 6. So we want this to, with a pre-walk, we want it to come out 1, 2, 3, 4, 5, 6. Okay. So we start with 1 in the list of nodes to visit. So we visit 1, we add its children. So now it'll say 2 and 5, right? But we don't visit 2, 5. That would be a breadth first. We're doing depth first. So what we want the next iteration to look like is 3, 4, 5. So basically, when you pop something off of this, you inject its children at the front. And then, so when we went through this, then after you pop 5, you would put 6 in there, and then there would be nothing left. So I'm convinced we need a vec deck for this. Yep. Okay. What's a vec deck? It's basically a queue, a double-ended queue. So we're going to use standard collections vec deck. And why is it a vec deck? Well, it's implemented. It is a deck, but it uses a vec or 2 vecs underneath. So, so our stack is going to be vec deck new. Did I spell that right? I don't think I did. Vec deck. No, I did. Hey, how about that? Okay. So vec deck new, and then we're gonna say stack.push. This is be push back. I guess it doesn't matter since we're putting, so we get the root node. Okay, so okay, so we're looping until this thing is empty. So what we want to do is say let the current node stack.pop front. So in the case of our list here, we're taking we always want to take the first element. That ensures that we're doing the pre, right? And then if we are now, before we do anything with it, we need to take its children and splice them onto the front. So we're kind of pushing things that are already in the queue behind these. So let's see how we can do that. Let's go to the vec deck docs. I often use vec decks in Rust to unwind recursive algorithms into iterative ones. So at the cost of a little extra memory, you can have it like all in one function as opposed to recursing. Recursing would be like the easier way, of course. Okay, so we want to. So we were using pushback, which is the standard append. Let's see. So extend is going to be basically like pushback on each of the items. So I think we want to we don't want any of those. We don't want to swap. I think we'll do it the brute force way. So let's switch tabs here. Yep. So we've got children Okay, so here we need to get a tree cursor. Now this is actually maybe the way that we should do it. Tree cursor. Oh, okay. Well, let's not do this the hard way then. Honestly, I think what we can do is we could probably use this tree cursor instead. I think I'm doing this the hard way. Pretty convinced I'm doing this hard way. Okay, so let's leave that for now. Maybe we'll come back to it later. I was very concerned about implementing this correctly myself, but we can just use this cursor and get the current node for that. So let's do. So if we call tree walk, we get a cursor, and it starts from the root of the tree. Okay. So on this easel, we need to basically like not think about this. What we need to do is think about the how we would implement this. So we're gonna start here. We'll hit 1. We'll go to 2 next, and then we hit 3. And here's where it's different. So we're always trying to go to child first, sibling second. Right. So 1, 2, 3, 4. No more sibling. Go back to the parent. Are there any others? Are there siblings? Yes. We go to 5. And then we go to child first. 6. No more siblings. Go up a level. No more siblings. Go up a level. No more siblings. Go up a level. We're at the empty. Why do we want a litter representation of the tree anyway? It's really about the fact that we can't pass these data structures back. This is a good question though, Isaac. You can't pass these data structures back to Elixir in any shape or form because they are bound by the lifetime of these data structures because they borrow from them. And as soon as they go back to Elixir, we can't guarantee the safety of or validity of that structure. This is why I want the option of being able to walk it. Now, ideally, I would love to pass back an iterator, like an opaque data structure that you would say, hey, give me the next node. And so you could use things like stream on it potentially. Also, I'm not sure if any of you have looked at the internals of Absinthe, which is the library that lets you implement GraphQL APIs on Elixir. It has some interesting things. So like if you wanted to instrument it, for example, it has some interesting things about walking around the tree of the GraphQL query that you passed. And they're expressed in terms of pre-walk and post-walk. So now what they do is actually they have an in-order traversal only, and then it's just a matter of when your callback gets called. That's another thing that we could potentially do is say like pass a function to the iterator, and then you'll just get nodes passed to that function. I'm not sure how valid that would be in this. I think it would be better if we could have an iterator. My brain, I'm going to do the simple thing first, and then if we see some pattern, then we can make use of that pattern. So we need the cursor, right? Right. Let's go back over here. So we call tree.walk. Okay, And then we're going to make an output vector. Yeah, so the current node struct that goes to Elixir has no relative links. That's that. Um, and it looks like the API of Tree Sitter doesn't let. Oops, goodness. It doesn't let us find a node just by its ID. So we're unable to take advantage of any sort of thing there, where you could just look up a node by ID given a tree. That would be ideal. Then we could say, well, we're just going to emit IDs of the nodes, and then you can go find them if you want. We don't get nice things. Okay. So what we want to do, I'm just going to do one iteration, and then we'll see how we can turn it into a loop. So we assume we're at the root node. So what we want to do is we want to get the cursor dot. So we're just going to push node from TS node. Again, here's a case where we don't have the source. So we're going to say the cursor dot node, and we'll borrow that, and none. Okay, so we have created our own node data structure from this node that the cursor is currently pointing at. And then we will do okay, so the first, based on our thing here, first thing we want to try to do is go to the child, go to the first child, and that note that this returns a Boolean. So we can say let's just we're going to do this with a regular loop. And then what we'll do is we'll return output down here. And we'll break. That's how we're going to do it. We're going to break on the condition that will where we have no parent, right? So yep. Okay. So we're going to do first, we want to try to go to the first child. Okay, so we're going to say if cursor go to first child. So this is always returning Boolean if it was able to move. So if there's no children, you're not going to go to the first child, right? So if we can go to the first child, then we continue. We go back to the top of this loop, and we know that we're at the first child, and we need to emit it. Otherwise, so we know that in our diagram here, we're going to go first child, and if there's no children, then you go to the next sibling. So we would go 1, 2, 3, 4. So note there's no children of 3, so we want to go to 4 next. Cursor dot. Now, actually, we could combine those two. So we'll do next sibling. Let's write this out, and then we will do. Then we'll go back and like consolidate some of the logic. So we want to go to the first child. If that doesn't work, then we're going to go to the next sibling. And if there are no next sibling, then we want to go to the parent. Except that when we go to the parent, here, let's do that. Okay, so here, uh, this would be like these are either going down the tree or going across the leaves. Um, so here we want to if you can't go to the parent, that's our termination condition, right? Because you are at the root. So let's say you did all this, and in order note here at 4, if we have go to parent, then you don't want to hit the parent again. You want to go to the next sibling. So I think we need a little inner loop here, which is if you can't. So let's combine these real quick. If you can't go to the first child or the next sibling, then um, hmm. Okay, so let's put a little commentary in here. This is going down the tree left, um, and across the leaves. Then you need to go up a level once you've hit the leaf. So if there's no first child or next sibling of the current node, you need to what we're talking about here is going from 4 to 2, but not emitting 2 again. We need to try to go to the next sibling. Right? Okay, so actually, I think let's think about it one step at a time. We're at 4, we want to get to 5. Um, so let's just assume go to parent. Um, okay, so we know that if we can't go to the parent, so like we're at the root, then we break out of this loop. We're done, right? Okay. So everything else in here is about finding the next thing in the order. Um, okay, so in this case, we've already gone to 2. Right. So now we're going to search up the tree for things on the right. Okay, so I think what we're going to do is we're going to go to next sibling. So here is as long as we are oh, okay. So I'm going to break these apart again, and here's why. um, and we're saying this is going across the tree. what I want to do here is we are trying to either go across or go back up and go across, right? So if there's no next sibling, we need to go to the parent. If there is a next sibling, we just skip this while and it goes back up to the top of this loop. And I think I need to make a label here, outer. Um, and I've never had to do this before. Okay. So if we have a next sibling, it's just going to go back up here. Um, Otherwise, we're going to try to go to the parent. And here, let's make sure that that's right. Go to, not go to, not go underscore. Okay, so if there is no parent, then we want to break outer. So what is that doing? So we're saying if we have no next sibling, we're going to try to go to the parent. If we're at the root, we need to quit because we have exhausted all of the tree. If we're back up at the root again, if we're not at the root and there are no sibling and there are no siblings at this level, we'll go up a level and try to find the siblings of that level, right? So that is the case of let's get this so we can see both of them while I'm looking at the diagram. Okay, so let's walk through this because I want to make sure that I get this right. This isn't a lot, right? But this is a little complicated. Okay, so when we start at tree dot walk, we're at the root node. And we enter this loop and we push on the root node. And then we attempt to go to the first child. Yep, we got to 2. So we go back to the top of the loop, we push 2. Okay, and then we try to go to the first child. That's 3. Yep, that succeeded. So we go back to the top of the loop and we push 3. And now 3 has no children. So go to first child is going to fail. Okay, so then we hit this while loop. Go to next sibling will yield 4. So we will not enter this while. This while will not be entered when we're at 3. So we will move to 4. Okay, and now we are at the top of the loop again. So so then we'll push 4 onto the collection. We'll attempt to go to first child. There is no child. Okay, and then we attempt to go to next sibling. There is no next sibling. So we go into the loop. We go to parent. And there is a parent. 2 is the parent. Right? So the cursor is now back at 2. And we say go to next sibling. That gives us 5. And that succeeded, so we go back to the top of the loop. And we put 5 onto the output collection. We go to first child on line 52. And we get 6. So we go back and we push 6 on there. Right? And then 6 has no children. So it says go to first child. That fails. So we go to next sibling. There are no siblings. So we go to parent. We're back at 5. It says, and so we're back at the top of the while loop. Go to next sibling. There are no siblings. We go to parent. So we're back at 1. And then we attempt to go to next sibling. That's false. Okay, so here's a bug. So we're back at the root. There are no siblings. Oh no, wait, I'm sorry. That's not true. So we're going into the body of the loop because there are no siblings. And then if we do go to parent, it returns false. So we break out. So I thought we were going to end up back up here and push 1 on there twice. but we didn't. Okay, I think I'm satisfied with this. Wow, interesting, right? Not how I expected to write this, but it should work. Let's compile it and see what the compiler says while I have a bite of popcorn. Okay. Let's mix compile. Okay. So I have a problem here, and then I didn't declare that variable to be mutable, and I called a mutable function on it. So an exclusive function. And it didn't complain. So let's give that a try. And unfortunately, I didn't do a script to set this up again, so we're gonna have to do all that gunk again. And maybe for next time we'll have that set up. Okay, so we've got the source. Let's get a parser. Parser new Elixir. And let's get the tree. Parser parse. And that takes the parser and the source. Okay, and then let's do tree pre-walk. And we got a bunch of nodes. How about that? So that worked a lot better than I expected. Now, what we're going to have to do, because we don't know let's just look at so let's see the collection. Let's get the -1. Okay, so let's look at head of collection. Okay, so the first node is the root node. So we starts at row 0, column 0, ends at row 35. So the next one, let's see, enum.add. Let's just do that. Collection 1. The next one is a comment on line 0. I notice we don't have the text of this, so we don't actually know what it is, but what we can do is look at the source of this file and see if that jives, right? So the first thing is a comment on line 1, right? Okay, let's look at what the second thing is. Second thing is a call on row 1, right? Column 0, and ends at row 34, column 3, right? So this is the def module. This is call. Now we didn't pass text to it, right? So it can't figure out what the text of that node is. But maybe we'll provide another option where we can pass the text in. That would be interesting. Okay. So I think I'm convinced. Let's look at the third element, or the fourth element rather. And we are getting row 1, column 0 to column 9. This is an identifier. So there's column 10, there's column 9. There we've got, yeah, this is like 0 index versus 1 index. When you're up here, it says it's line 1. So that's this def module as an identifier. And I bet this will be the arguments. Yeah, so arguments, tree sitter, row 1, column 10 to row 1, column 24. Cool. Okay, now we could do a post walk as well, but I think this is pretty good. Let's see. Let's take let's make a commit here, and let's look at the diff real quick. So we added getting the root node of the tree. we added the pre-walk, right? And those are in the NIF. Clean up that comment real quick. Yeah, the things that we commented out, can clean those up. Cool. Okay. Let me remove that vecdeck from this file. We don't need that in there. Native. Okay. So what did we do? We improved contents of node, tree sitter.node, and added pre-order traversal of the tree. Cool. Okay, so let's start to make more of a high-level API. Let's switch to Elixir for a bit, because I think it's probably important. You know, we did have those query things in here. Maybe we'll move that. Yeah, so we need a high-level API, and maybe we'll do we're going to make a parser struct, right? So and that'll just contain the inner or the resource. Let's say parser. And I think that this should probably be opaque, but I'm not going to bother with the dialyzer stuff right now. So let's make a new function, and this is going to take the language. And we might do something like check is that language available, and raise an error or something. So yeah, let's look at doing that. Unless I think that's what we called it. Language supported. Raise runtime error. Language not supported. Oops. We could probably make our own error type, error struct there. I'm not going to bother though right yet. Okay, so our NIF here. Right, this returns a result. So honestly, we could actually just call it. Yeah, let's not do this. Let's do case parser new language, and this if it's error anything. Oh, folks, is it single arrows or fat arrows in Elixir? I forget. Oh shoot! This is what I do for what I get for not writing Elixir in a while. You know, we could do it as with else. The thing that bugs me about this with Rustler is if it should return okay wrapping this thing, but for whatever reason that NIF result type is not converting in the way I expected. So so we'll do okay, and then okay, so we can create this parser and we've wrapped it up. So the resource now is down in here. We don't just have a bare reference. And I think we're actually at the point where, because I'm just changing the Elixir code, oops, we can just run this in mix and recompile as needed. Okay, so let's say tree sitter dot parser new Elixir. Okay, and then so we get okay. Now here's a question though, is like, should I return the struct directly or should it return okay or error? Let's pass something that doesn't work. So we didn't compile in CSS support. So it says errors unsupported language. That's fine. Okay, and then we can put that down in there. So let's make parse, and this will take a parser, and it'll take the source, and we can say case tree sitter NIF parser parse, and what did our NIF require? So it takes the parser and the text. So we'll say parser.parser, right, and the source. And if that returns error, otherwise we're going to say if this returns a tree, then we're going to want to say okay, tree sitter dot tree, like that, and we'll make a new struct for that, because I don't think that we're, yeah. Oops, and I need to do end. Okay. Yeah. And what we'll do too is, like, we have that node thing over here in the query module. We'll move it out here because it's relevant to there. And we won't have a new function to construct this, but let's do the root node, or just root. How do we feel about root? We like that? Okay. And this takes the tree. And what I'll do in a second is I'll go up and like pattern match this a little better so that we can actually, you know, people will get exceptions if they pass the wrong thing. Okay, and this will be resitter. So the funny thing about this is it's starting to feel like a lot like what you see in Rust libraries, where they'll have an unsafe crate, which is just the bindings to some C library, and then they'll build an API on top of that where they're using all the low-level functions inside that to create a safe API. That kind of feels like what we're doing here. Tree root node, right? And actually, we need to do. Let's pattern match on this, like so. And that we know returns a node. Okay. And let's see. What did I do wrong here? Oh, need the struct thingy. Yeah, I need to recompile. But it's there. Okay, let's just mix compile and see what happens. Okay, cyclic use in our... Is it just that it's not defined before? Surely that's not the problem. Or did I define it over here in query? I don't think I did. No. Oops, that's the wrong thing. Query capture. No. Let's get all these things that are not specific to queries out of this file and put them in lib. Treesitter.ex. Let's put them in here. I probably have a typo here somewhere. So parser has the parser internally. Trees up here. I would prefer to have it down here. Tree cursor has an into raw to get to rid of the lifetime. There's an unsafe function to get back to the tree cursor. But I think you can create a safe abstraction on top where you pass a ref to a tree so the tree will be alive and do a runtime check that the cursor points to the given tree. So I might have to check that pointers are equal. Is that what I'm understanding there from your comment, Isaac? That is an interesting idea. Of course, the into raw, I'm guessing, yeah, that returns a pointer, probably. That's usually what those things mean. I don't see into raw on tree. Or is it on node? Node have an into raw? No, I'm not sure what you're talking about. Oh, the cursor has an... Yes, the cursor has an internal tree pointer. Of course, yeah. Let's look at that real quick. Yeah, I don't see that into raw anywhere. Are you sure it's not just in the source somewhere and it's not exposed outside the crate? Or not documented? Let's look real quick. Okay. Well, we could potentially look at that later. I think what we have for now is pretty good. You know, I don't know that in this case that we are needing to optimize for efficiency and sharing. I would love to have a more ergonomic API for the iterator for sure. I might not be smart enough to do that. We'll see. Okay. Let's figure out our compilation problem here. What did I do wrong up here? Okay. So let's pattern match on this. I don't... make sure the struct name is correct. The struct name exists, and you likely have a cyclic module usage in your code. But I don't. What is going on here? Now, I could potentially do something like this. But honestly, that I don't know that that gives me anything. Yeah, let's not. Except this needs that. I need to construct it. Does anybody know what's going on here? Let's just mix clean and compile again and see if we can fix it. That did not fix it. It's not in here. It's not in this file. Okay, so we actually don't need that root module. I don't know why this particular thing would not work. And there's no typo there. Right? And we're not referring to those structs in the NIF module, so I can't tell what's going on there. Let's try for now. Let's try removing this function or commenting it out and see if the rest of it compiles. Yeah, that compiles fine. Let's do, let's uncomment this, and then it's really strange to have a compiler error there. And see if it see there's a warning there or something. Yes, source is unused, parser unused. Okay, no big deal. Let's do just this line. Okay, so it's not there. It messed things up for me. Let's put parens around that. Just say other, and we will deal with that for now. Okay, doesn't have a problem with that. Let's rename that to tree and see if it complains. Probably not. Okay. Getting somewhere. uh, get rid of that. And then it complains. Okay, so why? This doesn't refer to parser at all. So there's no cyclic. That is really bizarre. Note that it doesn't complain when I do that. Now, what I could do is do struct like this. That is strange. Did I just hit a compiler bug? I think I had a compiler bug. I have never had this happen to me before. That is really bizarre. Elixir version. Yeah, I've got 1.15.7 on Elixir or underlying 26. Okay, your guess is as good as mine. But let's move forward and on with life. Okay, so we need to do. We wanted to pre-walk the tree, and let's put this pattern match in there again. Oops. And then we'll do tree sitter dot NIF tree pre-walk, right? And because that returns, it returns a list of nodes. We really don't have anything else to do there. And then we've got a high-level API. I am really weirded out though about the fact that I can't, use the struct syntax like I did here in this spot. That is a really strange compiler bug, I think. But using struct here is fine. Like it doesn't, I don't think it impedes readability at all. It's just sort of like, why did that occur? Whereas, this, which actually just calls the underscore struct, why this wouldn't work. Okay. So I think what I want to do is I'm going to delete this module. We don't need it. There's nothing in it right now. And let's maybe finish off today by writing a quick test and see what we can. And that's more. It's not so much about making sure that this works correctly, because there's honestly so little Elixir code here. For me, this is more about, let's get an idea about how we can write tests for this, and also kind of reify some of the examples that I've been doing manually at the console. So thanks for bearing with me on all this, and then we'll wrap up and you all can go back to your Sunday. Okay, so we have this XUnit case, and it doesn't do anything yet, right? So let's just make a test. Let's see, creates a parser. Now we aren't testing we aren't testing the other languages specifically. We might want to do something where we do we do a config for test mode, right? Because we do this here. Maybe we do a config for test mode, which is like includes all the languages. That might be reasonable. But for now, we'll just go with Elixir. Why does that come out green, my dude? That is weird. Okay, so let's say then we're going to use the high-level API here too, not the NIF API. So let's say assert OK parser tree sitter parser new Elixir, right? And then one thing I don't remember if we did, we'll have to look at the native code again, but I think if we did, I don't remember if you can deserialize something that doesn't match here. This unit enum, like what happens if you, well, let's test it real quick. So we'll do the low level. Foo. Yeah, so you get an exception. What I'm not sure about is, maybe we should look at the docs for that on Rustler, because what I would prefer to, other than raising an exception in this case, maybe what I want to do is be able to return something that like actually has a value you can check on. Docs.rs Rustler. Okay, so there was the NIF unit enum we were using. Derives implementations. Okay. Each constructor is required not to have arguments. So invalid variant is returned if user tries to encode something that isn't in the Rust enum. But what about decoding, I think, is the question. NIF untagged enum. Oh, that's for if you have disjoint types. That's not what we want. Tagged enum. Okay, so yeah, so we could do something like this rather than unit enum. The question in my mind is, yeah, that's, Okay. Well, yep. Let's go back to our test. I don't think we really need to solve that right now. And maybe what we'll do is assert raises. And that takes a function. And I think right, so if we say parser new for that, believe that was what it was in Elixir Erlanger. Yeah. Yeah, so it's just an exception. Okay, so what do we do on assert raises? Assert raises, or assert raise, exception and function. Yep. Okay. Tree sitter dot parser dot new invalid language. We know that this will always fail, right? Right, so let's real quick mix test and make sure that this is fine. And we're compiling the NIF again for test mode. Okay, so so we know that works. So let's do parses, and let's say parses an empty document. That'll be a good sanity check, and we can just copy this. Okay, tree is tree sitter parser parse, and then we'll say it takes an empty document. And actually, if I recall correctly, when we were playing with that before, an empty document doesn't work. But we can try it. Let's see. Yeah. Parser. Okay. And we can do something here like we don't care if this is if what the contents of this are, but we know it's a tree. That's a pretty reasonable thing to do. Yep. Okay. Let's say parses a single comment. Like, this is, you know, I think we're getting to the point where this is pretty good. We can start. Oops. Adding more interesting things, and then if somebody comes along and they're like, hey, I found a bug in your code, we can address it. So this is a comment, right? And just, you know, building up more confidence in what we've got. Okay. And then if we need to expand the languages that we're supporting here, we can make language-specific test files. We could do something like have a harness that just creates the parser, and then you know, reads files to simple module. You know, and we can just have a list of the test cases to try and cover specific things. Foo, do, end. And let's, yeah, okay. So I think we're pretty good. Let's see. Let's say gets the root node of a tree. And let's copy this. And we'll say this is tree. And then we'll do assert tree sitter node, right? We want to say tree sitter dot tree root. And I would love feedback on this for all of you who are watching or watching on YouTube later on this recording. Um, Let me know if this sort of API makes sense. You know, it's kind of oriented around the data structures rather than oriented around, you know, fluent functions that you could pipe from one to another. I think in some cases for where we can return an error, um, it might make sense. You know, we could just return this bare and raise exceptions. I would love to know what you think about that. Um, if you prefer exceptions or you'd prefer to match on OK error. My gut feeling is like for now, for safety, let's match on OK error. There's not a real good reason for us um, to get exceptions raised. So let's see what other things they'd be doing here. Yeah, so you can parse. We can get the root. We can get pre-walk. Gets all the nodes in the tree in prefix order. Okay, and we can do this. And let's say we're going to say that there's at least one node and then any number after that. And there's not really a good way to assert that this is the root node. Maybe if we go back and we do that parent ID thing that I was talking about, adding that to this struct, then you could look at say like this node and then the next node and make sure that the parent ID for that second node is the ID of this first node. But right now I just want to get gets a little sanity check there. Yep. Okay. Let's do a let's do executes a query. That's a good thing to test since we spent so much time writing that stuff. And we can say, but we didn't actually we didn't actually build anything interesting there. So we just have the NIF functions. Here's a thing we should do that we didn't do. And I think I talked about this before. But in order to make this more ergonomic, what we're going to do, this is going to have a language in it. And then we will put that in here. Right? And we will match it here as well. And I think what we want to do is because we want to track the language that's going on in this tree, right? That way, if we have that, now this is, the tree is not necessarily strictly one language. You can have embedded languages. But for this case, I think that if we have this, we can do something like make a query function. Because we had this very bare one, we can pass the tree and just say here's the query, and we might even do let's go even farther, and because we're passing the source here, let's put the source into this struct as well, and then we have it if we want it. Now we didn't implement passing the source here, but we could add that, right? But we definitely want to do it for query, right? So then all they have to do is pass. So we'll need to, we'll need to pattern match all of this out. And maybe, let's just pattern match it out. So they pass a tree, and then they pass a query. And what we do is we call the NIF. But since we have these in the struct, we can pass it in directly when we call the query matches. We pass the tree, and we pass the language, and we pass the query, and we pass the source. Okay, so now when we're executing a query, we can say, let's get this, and then we probably need something for language, because we spent so much time doing that. A high level queries language, and then this will call the NIF. And we can say supported question mark. And we can call the NIF for that too. A little bit of indirection here that I'm not really happy with, but it's starting to shape up. Okay, so we created an Elixir parser, we created a tree. Let's this is going to be query matches, query match, right? Fine. So we'll do tree sitter.tree.query, and we'll pass, let's say, assert highlights. Right, is tree sitter dot language dot queries for Elixir, and we'll pass highlights, and we'll see if I blew it up. Let's find out. What did I do wrong? Okay. Did I not define that function? Oh, my Rust brain got in the way. We have to pass the tree, right? Okay. Cool. All right. What creates a parser, right? So up here, let's do that pattern match on there. Okay. Cool beans. I think this is a good place to stop for the day. Thank you for hanging in there. Let's make a real quick commit. And we'll say fill out more of the public API and add a few tests. Cool. Except I have to add them. Okay, and I remembered to push this time. So yeah, this is a good place to stop it. Thank you all for joining. If you have any questions, I'll stick on here for a few minutes, or any comments. Love to hear from you. And again, thank you for attending. Cool. So I'll just watch for comments for a few minutes, and then we'll call it. Thank you, Isaac. 2 raw is only on master on tree sitter. Yeah, and I one thing, or in 2 raw. Yep. One thing about that is that we'll have to think really carefully about how we will want to use that potentially, and if it is something where we have to forgo some of the safety that we built into this API, it might not be smart to just drop down to the pointers. As long as there's a from raw as well as an into raw, we could probably do some tricks, but still having all of that wrapped inside a mutex means that, and making sure that we are not sharing things that have lifetimes associated, means that we don't have to worry about tracking that resource usage ourselves. So I think that there's a less safe way to go there with if we do get the raw pointers. But we will have to do stuff like potentially track those raw pointers ourselves in a data structure that we keep around, and then make sure that they get cleaned up. I do. It will require, if we do go that route, it will require a lot of thinking to make sure that we're not leaking pointers. Now, as long as there's a way to check that pointer points to something valid before we reconstitute the higher level data structure, then I think that it'll be okay. It's just that when we get into that realm, we have to think not only about what is the lifetime of the things that the tree sitter library creates, but also what happens if, well, so the base thing is obviously if we end up on a different CPU thread, is that thing still valid, or is something happening on another thread? And if we allow our Elixir data structures to be passed around to other processes, which I don't really know that there's a use case for that, but like maybe there is that I'm not thinking of, then we have to be extremely concerned about, is this node that I got the raw pointer for still valid, or was that resource that I created that contains the tree, was that garbage collected on a different process? And I don't actually know what will happen there. I think that, it's inside a resource arc, which is sort of the thing that let Rustler work with Erlang's the Beam's internal resource reference counting. But what if you have this pointer out there? How can we tell the Beam that it can't garbage collect that tree until all the nodes referring to it are no longer in existence, have been dropped? I don't know that there's an easy way to do that. I can look real quick, but I don't know that it's. Yeah, that I think that way lies madness. It would be really, really neat, but we'll have to think really carefully about that. Now I could see sort of a middle ground potentially where the list of nodes are the list of nodes are like stored with the wrapper for the tree. Um, yeah, so the cursor is not a pointer, but the bookkeeping data, sure. But you, I still don't know if that cursor would be safe to use. And well, I think the Rust API would not allow it in general. Um, but I don't know that it's safe to use if you might have other threads taking the lock, or if we switch it to a read write lock, which we may yet do. If they take the write lock, but you have a tree cursor outstanding, what if they go and they change the tree? Now that tree cursor is not necessarily valid. Um, so yeah, there's a whole lot of problems around that, and in my mind, like for now, I won't have to solve that problem until people actually use this library. And even then, I hope we don't. I don't know about you all, but I am immensely pleased at how far we've gotten with um, so little work. Uh, I have learned a lot about writing NIFs, and I think this is really cool. So if you're doing in general, if you're doing something in Elixir and you need a low level library, like God, I would write it in Rust with Rustler any day. I know a lot of folks are fond of Zig as well. Ziggler looks pretty awesome. It looks really appealing that you can write that in your Elixir code and it'll just write an if for you. It'll extract it out of the Elixir code. Um, but yeah, this has been a good experience. All right. Thank you all for your feedback and the commentary. And I'll see you next week, I hope. Have a good weekend.